welcome everyone again to today's webinar. This is the Digital Twins Gain Insights by Visualizing Real-Time IoT Data in Your 3D Design. This is one of a series of webinars that we're doing that show our product portfolio or our Vertex platform. My name is Jim Zawicka, and I'll be one of your presenters today along with Matt Hein. Before we get started, I do have a few housekeeping items to go over. Everyone attending the session today is in listen-only mode, but we'd love to hear from you through questions box in your control panel here on the webinar app. And you can also tweet us at VertexViz, V-I-S, and we'll be answering your questions at the end of the webinar today. So as I said, my name is Jim Zawicka. I have had a very long career. I'm a mechanical engineer from Iowa State University. Back in the 90s, this was just the beginnings of 2D going to 3D, and as everyone was starting to build 3D assets, one of the big challenges was viewing all of this in one time. And so I was at a company called Engineering Animation Incorporated, and one of the key early tools that we built was something called VisMockup, and we also created the JT file format. And so I was an engineer at that time, an applications engineer, embedding these solutions into big OEMs around the world. Ultimately, we got bought by Siemens, and we are now known, I guess, as the embedded viewer or VisMockup tool that you would see in the Siemens suite. But in general, the core application, the core tool we built really is what was sort of foundational in the generation of virtual prototyping solutions that we know about today. As my career went on, I was at big automotive OEMs, and then most recently I was actually at Caterpillar doing similar sort of, virtual prototyping, product lifecycle management, embedded solutions. I'm currently now the Director of Manufacturing Solutions here at Vertex, and what I'll do after I introduce Matt is kind of demonstrate how that tool, that solution, those sets of tools were very useful for a long time, but they're at the end of their serviceable life. So before I get into that, I'm going to go ahead and introduce Matt Hein. Matt, go ahead.
Thanks, Jim. Hi, everyone. My name's Matt Hein. This is a photo of me pre-COVID, and then I haven't gotten a haircut since, so that's, seems like a lifetime ago. I got my start in the 3D graphics area at the Virtual Reality Application Center at Iowa State. I worked on a lot of 3D data visualization type applications and mechanical engineering and material science. I was VP of product at a company called Workiva that was primarily aimed at financial services and reporting, sort of a deviation away from my career path within manufacturing and visualization. A couple years ago, I came over to be VP of product of Vertex, and today I will be doing a demo to show you how you can connect your IoT time series, time stream data sets to actual 3D engineering models. With that, I will give it back to you, Jim.
Yeah, thanks. So as I mentioned, at that tipping point between 2D and 3D, what we built, it was very good. It was in the 90s. No one had ever figured out a way to do massive models before. And ultimately, this solution was well adopted, but it was well adopted really in the engineering space, a little bit into manufacturing and downstream. Our intention, though, early on was to actually make this available across the enterprise. But with some of the pain points or some of the blockers that you're seeing here, we never really fulfilled that vision. So what were those blockers? Well, in order to get mass model visualization in the engineering space, there was a very expensive hardware cost. You had very expensive software, and then the learning curve even for the individuals was very high. And as such, companies generally weren't willing to make those kind of investments downstream. And therefore things just sort of trickled out, or you required brute force effort either from the engineering teams or from the people pulling the geometry, whether in marketing or service or procurement. Those were the groups who really could have used and had had a lot of high value to get this information available for use in their world. it was just very prohibitive to be able to do that. And again, as I said back then, it wasn't really feasible. As we've gone through the decades here, the methods to do that, have been really kicking the problem, relying on the hardware, give it heavy hardware. Even with cloud today, you think, the companies that do offer solutions that maybe look like they're comparable to ours, they're essentially kicking the hardware problem up to the cloud, relying on very, very expensive VMUs to, and GPU laden devices to be able to handle that. So Matt, if you don't mind stepping forward one. So what did we do? Well, there's three really core areas that we knew were barriers. You had massive, BOMs or bill of materials. So, we wanted to be able to create a platform that could handle millions of bottom lines without the necessary effort to prepare it for downstream. We wanted to make those instantly available for them. The triangles for polygons, it's the term that you're using to make the geometric representation of the geometry. You wanted to be able to have billions of polygons. Oftentimes in order for geometry to be used downstream, they have to reduce it down. They have to simplify it. Particularly when you have like a mobile device, a phone or a tablet, you're taking something that's very, very big as released from engineering. You have to reduce it down to almost nothing to be able to consume it in a end device. And we wanted to eliminate that. We didn't want any device dependency at all and have the exact same experience. And then one that doesn't get as much fanfare, but is probably the biggest problem, is predicting how many concurrent users you could have available on the platform at any given time. Some companies make the hardware decision to go ahead and get all this, buy the hardware, but then they fall over quickly with the concurrent users, or they can't even predict how many. And we wanted to eliminate that too. So those key three things were really what was important. And then fourth is that we wanted to make it cost effective. So in order to do this, we really got the team back together, the team from the 90s, a big part of that group, and as well, and with people like Matt, who have great knowledge in the cloud ecosystem, to kind of mix these two together. So as opposed to doing really hardware intensive activity to generate a highly high fidelity rendering experience, what we did is we completely rethought it. We have it at a CPU level, so it's ultra low cost. So you don't get these heavy virtual machine GPU laden hardware costs that come along that most of the companies that are doing anything in the cloud are doing for you. We threw that out the window. We totally rethought it, and that's what we're going to show you today. So the other part of this, by the way, is that you don't have to do the transformation. So I brought up that with the ability to, people are optimizing the models, reducing them down. This is a straight pull from the engineering world and making it available across the enterprise. So just to summarize, any size model, any number of users, any device, and really any device. There's no fit client, there's no install on the device. Essentially, you're viewing through a browser, you get a plugin, no plugins at all. You're able to go in and use it and have high fidelity models out of the gate. Next model, or next page, please, Matt. So how does this work? If you look at the bottom, with Vertex in the middle, what we're doing is we're aligning to traditional data sources. So whether it's your PLM, so product lifecycle management, manufacturing execution systems, your ERP systems, CRM, and then IoT, what we're doing is we're aligning to those data sources. We're not becoming a new master record, and we're taking 3D visuals and we're aligning the visuals to those contexts or to that data. And that includes metadata, it includes the 3D visuals, it includes the BOMs. And what it does then is we're able to then prepare it and deliver it in the right context for the right groups on top. So engineering may be seeing the engineering BOMs, manufacturing may see MBOMs, sales maybe like a customer, like purchasing experience, pricing experience, service doing assembly, disassembly. The point is that you're not creating separate data sets for those groups. Everyone's using the exact same 3D geometry, the exact same metadata. It's just all prepared and delivered in the right context for the right use case for those individual groups. So today, so if you look here and you think about digital twin, we broke out even a little more detail some of the use cases that you would see across, say, engineering, sales, plant floor, manufacturing, service. Today, what we're going to do is we're going to focus on the IoT and both product and plant floor. And so without further ado, then I'll just throw it to Matt, and he'll walk you through how the Vertex platform takes that that use case and makes it come to life.
Yeah, thanks, Jim. Yeah, so just to review some of the things that Jim was saying, the Vertex platform can pull in your PLM data, get that into a form where we can put an API around that, and then you can essentially embed that 3D view into any experience that you want on a website, on a mobile app, whatever it is. And once you have the ability to do that, you can connect that to all the different data sources across your enterprise. And that, as Jim was saying, from engineering to manufacturing to sales to the customer experience, service. And then today, what we'll be talking about is taking all of the IoT data that's coming in from either, let's say, a product like a wind turbine, or maybe it's from a factory that has more process type data. Maybe that data is coming from an ERP system. Maybe that data is coming from some other IoT ingestion device. Either way, Vertex can bring all that data in and put that into a 3D context, and we'll be showing you some of that here. But before I show you, one thing I want to talk about is like why would you care about doing this in 3D? Along with some of the things that Jim was saying, we can give you a digital twin representation of the actual thing that is as built, as designed, as is in the field. And so what that allows you to do is take all those data sources that typically, might just be some numbers or charts on a phone or on a desktop, and really bring all of that data to life to see it in context of the machine that's actually generating all that data. With that experience, you can really help you diagnose what's happening with that machine, be able to drill down and see all the different sensors and how all the different components are contributing to some of the output values coming out of the machine. The other thing that we can do with 3D is because we give you a 3D mapping, you can not only take all that IoT data, but let's say you can also take some ERP data and mash that up with the IoT data to give a really rich digital twin experience. And I'll show you that here in a second. So one thing I would like to talk about, I'm going to be showing some other functionality from Amazon Web Services today, specifically AWS Sitewise. Vertex collaborates with AWS Sitewise to have an integration where we can pull in the data from Sitewise, bring that into 3D, and so all of your assets and the asset hierarchy can be mapped into the Vertex platform and can be used to visualize that data in 3D. So with Vertex and AWS, we've had use cases in automotive and manufacturing. We've had a lot of interest in architecture and engineering with BIM type data and things like that. But today I'm going to be showing a wind turbine field. And so with that, I don't want to get too technical in this webinar, but here's a reference architecture for what you're about to see today. We have some IoT sensors coming off of various wind turbines in a wind farm. Using AWS, you can ingest all that sensor data, pull that into Sitewise and some of the other services that AWS has, like IoT Core, IoT Analytics, IoT Events, to start really building kind of second order applications on top of all that data. So instead of just pulling that data in and just housing all that data, maybe you're doing some sort of predictive analytics or something like that on it. What we can do with Sitewise is not only bring that data into a 2D dashboard, but then I will show how you can bring that data to life into 3D. So with that, I am going to switch over. The first thing that I want to show is just a little bit about the AWS Sitewise platform here. So what Sitewise does is allows you to model your assets within Sitewise, and then you can come in and I've got a sample wind turbine wind farm here. And as you can see, I've got 4 turbines on the left, and each one of these turbines has some measurements associated with that. So you've got RPMs, wind direction, wind speed, torque. These are just 4 sample sensor inputs. I've got some transforms to do some ETL type processing on that data. And what you can do with all of this is then bring it into a dashboard that looks something like this. So this is typically what you would see with an IoT application. You know, I'm gonna show you how to edit this dashboard here, but you can see I've got various charts for output power, wind speed coming in, RPMs of my input shafts. What you can see here is if I go and edit this dashboard, you know, I can drag and drop things around. But I'm not really here to demo Sitewise. What I want to show is what can you do with this data. Let's see, am I still screen sharing? Yep. You have my screen sharing?
You are, yes.
Yeah.
Yep, I can.
Okay. So I've got all of my assets modeled here. Now I'm going to switch over to this demo. So now what you can see here, this is a sample application that we made of with Vertex and AWS Sitewise. So going back to my assets that I have modeled, I've got, you can see here, what you're seeing here in green before I start stepping through the data, I had some of those sensors and some of those outputs mapped from the sensor values, and I created a mapping to look at all of my 3D parts and assemblies and say, you know, something like wind speed, I want to map that to the wind turbine blades here, right? And so this is what Vertex gives you. This is an actual data set of 3D geometry coming out of a PLM system. As you can see here, I move my mouse and I can get interactive 3D views. Well, you know, you could say, you know, so what? I can do that with other things. Well, the really interesting thing about Vertex is we can do very massive models that something like WebGL wouldn't be able to do. So, you know, for something small, you can use some of the WebGL technologies out there. But for Vertex, something big like this, we do all of our rendering server side. And so, you know, let me just click refresh here. So when you are using Vertex, the image comes in instantaneously, where using WebGL or something like that, you'd have to stream all the triangles to the actual user device. They would have to use their GPU on their phone to or their laptop to render that. So with Vertex, I can do all the server-side rendering, so I can get very large models. Like let's step over to something more like a factory. So, you know, one single wind turbine might not be that impressive, but an entire factory, you're going to have lots of different sensors. You're going to have a very large, complex model. And with this, I can take all of my machines and map values to create a, let's say, a process digital twin. And like I was saying, we've got customers that are not only using the IoT data, but they're also mapping and visualizing their factory with, let's say, ERP data coming out of SAP or something like that. So going back to the demo here, you know, like I said, all of this data is real time coming out of Sitewise. Once you have all of your sensor mappings, what you can do is use the Vertex API to set up, you know, essentially like conditional triggers on how I want to visualize this 3D data. And what I'm going to do here is this data set, because it's live, is fairly uninteresting. But I'm going to hop over to this other data set that I have. So basically, same wind turbine. This data set is actually a little bit more rich. I've got 34 different sensors mapped to this particular model. And so you can think of all the sensors on the wind turbine coming in. I can map those to any parts. So, you know, think about gearbox bearing temperatures and things like that. Well, sometimes I want to maybe, instead of just mapping that to the actual low speed shaft right here, instead of actually mapping it to the bearing, I might want to visualize that on the actual shaft itself. It's really up to the end user on how they want to create a 3D digital twin with Vertex. Some of the other things that you could do here using something like AWS IoT events. Events allows you to set up conditional triggers to say, hey, this wind turbine is supposed to break at wind speeds over 55 miles per hour. For some reason, this wind turbine out in the field did not break as fast as we thought it should. There might be something going on with the brake. So you can actually get that timestamp, click on it, and then remap that data. So then I could go through at that particular time and say, hey, what was happening at this particular point in time? And maybe, and there we go, that was the issue. So I can come in here, click on these parts, maybe pull up some 2D dashboards, like I was saying, from the Sitewise to really see what's going on. But that gives a pretty comprehensive view of a sample application that you could create with Vertex and something like AWS Sitewise. Really, the Vertex API is extensible to any data source, and like I said, we've got customers that are building applications with ERP data, with MES data, certainly with existing PLM data, and now we are just showing off some of the IoT capabilities. With that, I will hand it back to Jim.
All right, thanks, Matt. So in summary, and so we'll just summarize here a little bit, and then if you have questions, please put those into the box there, and we will try and answer them. We already have a few, so if we don't get to them, we'll respond to them offline. But so the Vertex platform really is meant to provide rich access to high fidelity visuals downstream. Today's focus was on IoT. We also have other webinars across the board. So I think the summary is really, really good there. I think we've done a good job of, hopefully done a good job of explaining it. So let's go ahead and hop to some of the questions with the time we have left, Matt. One of them here is what PLM or ERP systems can you connect to? I think either of us can answer that. We do offer APIs or REST APIs that can go into all of the top PLM systems, PDM systems, ERP systems. So whether it's the Team Centers, the Windchills, the Innovias, or the SAPs, or whatever MES system. Even if you don't have an off-the-shelf one, if you have your own customized one, we generally have a set of tools that can connect. Oftentimes it's a little bit of a hybrid of their APIs and our APIs, but we can connect nicely. Is there anything else you want to add to that, Matt?
Yeah, I mean, we support over 25 different file types to bring in your data from your PLM system. As Jim said, we have an open API for pulling all of that 3D geometry in, along with the associated metadata. Vertex was born in the cloud. We're an API first development organization. And so all the APIs that we use internally to build our own applications and capabilities, we expose those for the customers to not only import their data, but like we're showing today, visualize their data as well.
I think one other thing to mention here is we're not becoming a new master record. The sources of the data are still the master sources. We align to them, and then even events that say in your PLM system something's been updated, an event would trigger, and the latest representation would come into the Vertex environment. And so we're always aligned. We're not a new master source. Some of the IT people get sometimes a little bit nervous that we're creating a whole new set of data that they have to worry about, and that's not us. Let's see here. Matt, I'll give this one to you. How does the mapping from IoT to 3D actually work?
Yeah, I talked a little bit about this, but I'll go into some more detail. So when you import your data into Vertex, we import the parts individually and essentially create a library of different parts, and then give you a way to, either that data has a configuration coming in, or we can take dynamic configurations to show, like for the example, this wind turbine, you might have a 1 megawatt platform or a 1.5 megawatt platform, and there might be some part reuse in there. And so we can tap into that ability to bring in all those parts. Once you do, then you say, okay, I'm going to model, my asset with this configuration. And then for this particular asset, I want all the sensors and all the metrics that are coming in. Let me look at those and say, all right, like I was saying, wind speed, let me map that and let me find the 3 turbine blades and then create an association between those two. And so now I've taken something that was a time series data stream and created an association to that set of parts. Then let's say wind direction. How would you visualize wind direction? I mean, that would be something that you could, let's say, take for example on the wind turbine nose cone, and I might create some sort of mapping to show the rotation of the part itself. With that, we also have the ability to do some transforms so that you can rotate maybe the wind turbine in the field itself. So there are different mappings with that. And like I said, the thing that we're showing today was primarily around data visualization using colors. So now, once I have that mapping, I can create different thresholds and say, the operating range for this wind turbine is, between 10 miles per hour and 55. If it's within that parameter, maybe I don't want to visualize or color anything. Maybe I want to only show when it's maybe stopped or above that threshold. So that's, it's definitely something that we could walk you through, and it, the way that Vertex is set up, we're very scalable. So I showed the example where you've got 34 different sensors. If it's a factory, I mean, you might have thousands of different sensors and try to figure out how to do mapping in Vertex, because we're all scalable from both the model size and user scale using our cloud rendering engine. We can certainly do a mapping as large as a factory.
Good, thanks, Matt. There's more questions, but we're kind of running out of time here. So I think what I'll do is wrap it up, and then anyone who asks questions, we'll respond to you through however you registered with the webinar. So let's see. We will be sending out a recording of this webinar as well as a slide deck and a couple of additional resources about the digital twins tomorrow. You can always visit our website at vertexvis.com to learn more about our product offerings. And on behalf of Matt and myself, I would like to thank you guys for joining us, and have a good day.